Welcome back. This is HVAC Terminology 2, what you need to know. Ductwork is defined as a system of metal, fiberglass, or plastic that is shaped to run throughout a home or a building and that is part of the heating and air conditioning system. Ductwork delivers air to either cool or heat a confined space. Flare. Flare is a gradual widening. In heating and air conditioning, it's usually between 37 and 45 degree flare depending on the manufacturer of the fittings or the equipment. The first picture on the left is a piece of pipe that's been flared and has a flared nut on it. Next is a flared coupling, and then next there's a a double female adapter, and the last item is a flaring tool, which you'll have in your set. Flash gas. In refrigeration, flash gas is a refrigerant in gas form produced spontaneously when a condensed liquid is subject to boiling. I've pointed out on this slide the picture of a TXV with that dotted black arrow that shows where flash gas usually happens when the liquid refrigerant goes through the TXV. It expands a little bit right away, which means normally it's 80% liquid and 20% flash gas. But that as that passes through that evaporative coil, the gas continually flashes more and more off. As heat makes its way to the liquid refrigerant, it boils off and creates more and more gas to the time it gets to the top of the coil, where hopefully it's all spent and is totally 100% vapor or gas, and makes its way back to the compressor. Galvanic action. You see more galvanic action in plumbing than you do air conditioning and heating. Galvanic action is where you get two dissimilar metals. In this case, it's steel or sheet metal and copper. And the copper starts eating away at the sheet metal, and that wouldn't be very problematic with an air conditioning system, except for now when the system's blowing air and vibrates, that metal is now grinding on the copper. That causes a leak. It doesn't eat a hole in the copper, it just eats a hole or some of the metal away. But this is the side of an evap coil, and it doesn't take long, as little as a year before that happens. New systems are all made with tinned metal, so on the ends, if it's not already aluminum, on the ends of the coil they dip it in a tinning solution and they seal it completely so you don't get the moisture to it, which would cause this to happen. Glow coils are hot surface igniters. These are items that either they're low voltage or high voltage. You can do this with 24 volt, just depends on the size of the wire that gets hot, or they use 110 voltage. In this case, you can see the middle picture is one that's actually working, and what it does is the system sends a power source to that, the glow coil, the hot surface igniter, and it gets red hot, and at some point the gas escapes through the pipes it hits the hot surface and ignites, and then there's a flame sensor that tells it when to shut off the glow coil. But there on screen is two different types, at least the most common two types. Grounding. Grounding is a connection from one of the currents carrying conductors of an electric power system or of an interior wiring system to earth or ground. And in the pictures you can see on the bottom right, you have this is what most people see, a copper pipe or galvanized pipe coming out of the ground, and they'll have the copper wire tied to it and clamped down to it very tight. On the left-hand side, you don't see this as often because it's usually under the grass line as it shows, and it's when new construction they hammer in a 8-foot steel or a copper rod into the ground and clamp a wire to it, which is your ground. And the wire travels underground for quite a bit, so that works that way as well. The center picture is you see the green wire on the outside condensing unit, which is a ground. You have to make sure in installing equipment that you not only have a ground going to it, but the ground is active. You have to make sure it's connected and it's working. The reason why is if you don't have that ground, if the system is not grounded and it's off the ground on a plastic pad, if you have a wire that shorts and touches the side of the casing, won't always short out, but it will shock you when you touch it. And all HVAC systems have to be grounded for safety for the technician and the occupants of the home or the business. Hard start kit. These are called by different names. They're called a hard start booster, a kickstart. They call them a lot of different names. And what it is just another capacitor that stores power in its body. So when a system comes on, it will help the compressor move. If this was a 3-phase system, you wouldn't need it, but in single-phase systems, you need them. The first sign of someone that might have a problem or a motor that is sluggish and starts slowly is their lights dim when it comes on. If the homeowner's lights dim when the air conditioner comes on, that means they need a kickstart because the motor's drawing too many amps to get going, and with time will burn out the motor if one of these is not installed. Head pressure. Anytime a system's running, you have head pressure. And that black arrow pointing to the TXV again is the head pressure is created by the compressor pumping refrigerant through the system. And of course, when it gets to the TXV, the TXV meter's probably 1/50th of what's coming towards it. So now you have that refrigerant wanting to pass through, but it can't because the dam is holding it back and just letting a little bit at a time through. So at that point, you build head pressure, which is not a problem. The system always has some head pressure. But at a point when that TXV is not working or is clogged, that head pressure can build up to the point where it causes the compressor to fail. So head pressure is a serious thing to watch out for. And if you do have high head pressure, then there's a high pressure limit switch that you see. The one on the left is a residential system one. It screws onto a valve on the high side, and it's set for, say, 450 psi or 350 psi, depending on the refrigerant in the system. And when it gets to that level, those lines actually, that switch opens inside, which is connected to the compressor or the whole electrical system, and it shuts down the air conditioner until that pressure drops, and then it resets itself and it could kick on again. Unfortunately, some people go months and not know what's happening because it waits. The high pressure builds up when the house has been cooling for a while, it shuts down, cools off, and then comes back on. So there could be a high pressure problem that is, even with a kickoff switch, that's causing a possible problem and will cause compressor failure even though no one would know it. The one on the right side is a one for a refrigeration system, like a cooler or an ice maker or something like that. Package systems and split systems. These are both Goodman setups. The one on the left, which is a package systems, is exactly the same as the one on the right. It's just the components are in one box rather than two separate boxes. The package unit has some benefits. It's easier to install. I loved installing them compared to the split systems. You don't need Freon lines running between the two units on the right-hand side. The split system, they don't have to, that air handlers in the attic, you don't have to run the Freon from the downstairs outdoor system all the way up the wall to the attic. The problem with the outdoor system, the package unit, it doesn't insulate very well. It's not as efficient, but it does for lower first floors, and with a crawl space, it's a much better unit to have. It's just easier all around, but they work exactly the same. It's just being in one box and being in two boxes. Registers. No matter how well your system was designed or installed in your home, you will always have rooms that are either too cold or too hot, and other ones that are too hot instead of too cold. It's hard to get the ductwork designed perfectly. Tree shade changes, temperatures change outside. It's hard to make it work. That's why these registers were developed where the can be opened and closed. These louvers can change their position. And then if you have a room that is always too cold and you don't want the air conditioner going in there, you almost close it, or sometimes close it all the way. And rooms that have are a little too warm, you open them all the way. So you can go around your house and change these a little bit to get the right temperature in the right room. Someone might be too cold or too hot, and this makes it perfect for them. Reversing valve. These are used in heat pump systems, not straight air conditioning, when the Freon does heating and cooling. Out of all the things I've done over decades of working in air conditioning, this is my least favorite thing to do. And the reason why, you can see at the top of this valve, there's three, either 3/4, sometimes 7/8, sometimes 5/8 inch open pipes that move the air from either the indoor coil, the outdoor coil, and a return. To unsolder or unbraze all three of those at one time is almost impossible. I've tried every technique possible. I've bought special tools with long flames on them. It's just very hard to do. They're very difficult to do. And you'll see when you go through the brazing training at school, you'll see that unbrazing a pipe and putting another fitting on it is difficult enough, but when you have to do three at the same time, because these pipes are rigid and they don't move, it's not something that's easy to do. And on the right-hand video, it shows, or right-hand picture, it shows you how this works. Again, in one mode, the blue line goes in, comes in, goes right back out, and the red line comes in the bottom and goes out. Well, if that slide that's inside there goes the other way, it does the opposite. The red goes in and goes right back out, and then from the bottom, the red goes in and goes the blue way. So it changes directions depending on what season it is and how you have your heat pump set. Short cycling. Short cycling is a problem and can cause irreputable compressor damage. Normally you see short cycling, at least in the past you did, with a compressor that turns on and off because people are manipulating the thermostat to work better. And those were when there were old mercury thermostats or bimetal thermostats that you could do that with. Now modern thermostats have a 5 to 7 minute time delay before the compressor turns on when someone changes the temperature. So that way that compressor doesn't turn on and go off, turn on and go off. There's also when the unit is not properly installed or they're mismatched the size of the outside to the inside. That is also a problem that needs to be corrected. And some people get a really good deal on something that's not right, and they put it in their home and it just stops working properly. There is a lot of things that can be done to check for this, but usually short cycling stops a compressor from working. And how I mean this is, think about riding a bicycle and you're at a standstill and you start riding your bike and you're on level ground. It's easy to start pedaling and get moving. But if you're looking at a hill with a 8 or 10% grade and you try to get on that bicycle and start pedaling from a stop position uphill, it's very difficult. Well, that's what a compressor goes through. When a system shuts off, for about 5 minutes, that pressure is not equalized. The high side or the outward side of the compressor has a lot of pressure. So now that compressor's got to start pushing against stuff right away. It's difficult for it to do and can cause failure.